This is number 58. You are given in this problem an equation for the acceleration of a particle. This is what you call the initial velocity. Initial because it's when time is 0. And here is your time interval. Two questions. Find the velocity at time t. So what that is asking for is a general equation that represents the velocity, or general function. So what we do to do part A is we start off with the fact that the derivative of the velocity is equal to the acceleration. So if I want to get the velocity, I need to take the antiderivative of this. So the velocity is equal to the antiderivative of t plus 2t plus 3, which is, if I add 1 to the exponent here, I get t squared, then divide by that. Then the antiderivative of 3 is 3t. And I have a constant left over because the antiderivative, this is the indefinite integral. And so to get that c here exactly, I'm going to use this information right here. I'm going to use this to find c. Okay? So I'll give myself a little space here. So let's rewrite this. This is t squared plus 3t plus c. That's my v of t. And supposedly, when I put in 0 for t, I get -4. So v of 0 equals -4. That must equal what happens when I put in 0 for t here and 0 for t here. So that gives me c. And so my final equation is v of t is equal to t squared plus 3t minus 4. Okay, for part B here, I want to find the total distance traveled during the time interval. The time interval is from 0 to 3. And the distance is found by finding the integral from 0 to 3 of the absolute value of the velocity. The reason I need the absolute value is because when the integral is calculated, if there's negative distance, if it goes backwards, for instance, that would correspond to the velocity being negative, then the distance would be calculated as a negative distance. It's like it's going backwards. But we want the total distance covered. So even when it's going backwards, we want to consider that as something added to our total distance. And that's why we need the absolute value of the velocity here. So I've written it out. We found the velocity function in part A to be this. This is what I want to compute. I can rewrite it when I replace the v of t here with the actual function. There it is. And then in order to deal with the absolute value, what we're going to want to do is factor this so that we can tell when things are positive and when things are negative. So if you look up here, when t is in this region between -4 and 1, then we're talking about something that's negative. For instance, if I put in a -3, then this is positive, but this is negative. So the multiplication of the two would give something negative. And so that corresponds in here, v of t is less than 0. So if I put in something like a half, this is negative, and this is, or negative a half. This is negative, and this is still positive. So together, they make something negative. Over here, from 1 to 3, that's not true. Anything I plug in over here, this is positive. And then I'm beyond 1, so even 1.1 or 2, these are all positives. So over here, v of t is greater than 0. It's bigger than 0. So what this integral needs to be written as is two integrals. The integral from 0 to 1 where I use, this is my v of t, but in that case, it's going to be negative, so I need to do what the absolute value does. The absolute value takes a negative and it turns it into a positive. You can think of that happening by multiplying by -1. So I'm going to take this and multiply by a -1. And that gets rid of the absolute value. Okay, that's half of it, or part of it, 0 to 1, and then I have the other part from 1 to 3. And here, the absolute value is not even needed because we know that that term there is positive, so we can just ignore the absolute value. It's as if it wasn't there. Okay, so those are our two integrals that we need to compute. And I'll leave that for you guys to compute.